Hello and welcome back to another episode of E-Man Codes. I apologize. It's been a while since I recorded a video. Yeah, it's definitely been a while since I last recorded a video. I apologize for that. First of all, let's go straight into it. So, who should actually be watching E-Man Codes? So, if you're interested in technology, in coding, or in DevOps, cloud engineering, artificial intelligence, and you've looked at material online, you've looked at stuff online, and it's all very confusing, then this is a video for you. What I do is I try and break things down as simple as possible to just give you a very good, like a very broad understanding of what it is that we do on a day-to-day basis. And of course, you can then use the opportunity to dip your feet in, get a little bit of coding in there, and learn something about it. So let's get straight. Today we're going to talk about artificial intelligence. We're going to talk about machine learning. And in light of the fact that ChatGPT came out and everybody's using it, I think it's even more important that everybody kind of really explores what they can do in tech and learn coding a little bit. So we'll go straight into the content of this particular. So the first thing we want to clarify is what is TensorFlow. After making sure you understand what TensorFlow is, we will go into just looking at a very small commercial example and use case of TensorFlow. After that, then we'll actually do a live example, so a code along, which essentially I hope you'll be able to code along, and at the end of this entire video, be able to say to yourself, okay, maybe you've done a few machine learning code, and maybe that's something that you're interested in, and you can keep going. So yeah, let's get straight into it. First one, what is TensorFlow? So when you Google what is TensorFlow, you get this definition from Google, which is that TensorFlow is a free and open source software library for machine learning and artificial intelligence. It can be used across a range of tasks, but has a particular focus on training and inference of deep neural networks. Now, it makes sense that you see that, and that sounds very, very confusing. In the most simplest term, what you need to understand is that, first of all, it's a software library within Python is any form of code that you can use over and over and over again. It has no specific. It has specifications, of course, but you can use it for your use case as much as you like. And of course, I've also highlighted a deep neural network. One thing that machine learning really packs in is that the deep neural networks imitate. It's an algorithm essentially within machine learning that looks at the ways in which, as humans, the ways in which we learn, the way we process information. So, for example, when you were a child and you wanted to learn how to pick up a ball, you kept doing over and over again, maybe changing the style of your hand, until eventually you recognize that this is the way in which to pick up a ball. And the first time you do it, essentially a neural network is formed. And when you keep doing this over and over again, you teach yourself and you learn yourself. And essentially, deep neural networks is applying that similar concept and allowing a computer to be able to look at previous information, see the patterns of that information, and essentially go along and use that to predict and make better predictions for you. So just to recap what I've just said, in very simple terms, with TensorFlow, for example, if you have a set of data, and we're going to go into a commercial example soon. If you have a sort of a set of data and you want to learn the patterns in that data, and then you want to also go into a second set of data and say, okay, cool, with what I've learned from this previous data set, can I use it to predict the outcomes of the next data set? And of course, that sounds very, very hefty. So we'll go into the next commercial example here, and then you can understand exactly what I mean by data sets. So what you can do is you can give TensorFlow, which is the Python library, and we'll show you an example of a Python library is properly. You can give TensorFlow a Python data set. For example, the first data set here, what this one is doing is looking at the number of, this data is essentially a simple data. I'm giving it a list of factors about housing. So for example, the fact that it has 4 rooms, 1 garage, it's based in London, and using that information, it contributes to the ultimate price of the house. So essentially, this is a TensorFlow can be used in the pricing of houses model, for example, whereby the size of the house, whether it has a garage or not, the location of it, can all be contributing factors to the price of the house. Now, say you have a big database a massive database with thousands of information about, amount of rooms, the location, the garage, it has garage or not. You can then train TensorFlow to be able to say, okay, cool. If I gave you a different example, a different database where it has no price, could you use what you've learned about the previous model, the previous data, and can use that and extrapolate that information and then give me a pricing of that? So for example, off the top of our head, we might be able to guess, a 2-bedroom house in London with 1 garage, maybe it'll cost X amount. Now, with that degree of prediction, as a human, it might not always be correct. With TensorFlow, you can kind of get towards the 98, 100%. Well, not really 100%, but you can get towards the 98% accuracy and give you a pretty good pricing model. So that's just kind of commercially how you can use TensorFlow. But yeah, now that we've kind of talked about it, I'll just summarize quickly what we've learned so far. We learned that TensorFlow is a library. It's a Python library, so it's a bunch of code that you can use over and over again. Now, with this bunch of code, you can give it a database and you can train TensorFlow on that database, and then you can then use that training to then predict essentially the outcome of another database. So with that explained, we're going to go into a live coding environment, and we're going to essentially play around with some databases and then look at how we can make some predictions out of it. But yeah, I hope you really enjoyed this. It was very exciting learning about this and myself. I'm a cloud engineer by trade, and I think it's so important to kind of have your feet in other aspects of technology. But yeah, let's go into it. Brilliant. So now we can actually get straight into the into actually getting our hands onto some coding. So first of all, we're just going to quickly look at this graph. What we're going to use TensorFlow for is to predict with a given set of coordinates, with a given set of x coordinates, what the y-axis will be like. We're going to train it with these given sets of coordinates here. So essentially what we're looking at here, we've got this graph plotted quite nicely. We know the gradient of the graph is 2, and we know the formula for the graph is y equals 2x minus 1. I hope we remember from school when we were taught the way we find the gradient. Normally we take 2 arbitrary points on the graph, and then take the y-axis, find the difference between the y-axis, divide that by the difference between the x-axis, and that'll give us the gradient. And then c is always a constant that we substitute in there. So here, just to give you a quick example, if we took for the x-axis and then plotted it, or even used the graph here, we know the 7 would be the y-axis here. Now, question is, how does this actually relate to TensorFlow? Now, if you remember what I said about the commercial example with the housing graph that we looked at, if we gave it a number of inputs, which is, for example, the date, so the location, the size of the house, and even whether it has a garage or not, we could potentially come about, and I mean, that was a simple graph I created, so a simple Excel table I created, and that should give us the value or the price of the house. In the same way, with this particular model here, we can train TensorFlow to look at a number of different coordinates, a number of different x coordinates, training to look at the relationship between the x coordinates and the y coordinates, and then hopefully, if we were to give it an arbitrary number, like say x equals 15 or x equals 100, it would then be able to give us the value of the y coordinate based on the fact that it doesn't actually use it may not derive the actual formula of these coordinates. It will just use the pattern that it sees within that coordinate. So first of all, we're going to go ahead and we're going to use Visual Studio Code as our editor, and that was the previous test I run. Now, granted, you may not actually have Visual Studio Code installed on your computer. I encourage you to use Visual Studio Code. If you haven't and you don't know how to do it, that's okay. I'll be doing a video on how to install Visual Studio Code from all the way from the website to being able to interact with it. But if that's the case and you still want to be able to interact with this code along, this is actually deep learning, machine learning, so it'll be good for you to find a way. The way you can do is if you use Google Colab. Google Colab is actually a great tool. It allows you to essentially run the codes that I'm running within Visual Studio Code here. You can type that straight in here and then press play, and it will go ahead. So the first code I would actually be running once I've got the script set up will be import TensorFlow as TF. And if you run that there, it will go ahead and it will find TensorFlow, import it, install it, and pre-bake it. Brilliant. The reason why I think we should use Visual Studio Code mainly is because I'm a cloud engineer. If you're interested in DevOps, cloud engineering, all those kind of disciplines, then I think it's great that you actually use this opportunity to also practice some of the commands that you may use on a day-to-day basis. So the first thing I'm going to do is we're going to create the file that we're going to use to execute our script. So the command that we'll use will be touch, and then we're going to call the name of the file TensorTest.py. Brilliant. And then I want to create a virtual environment. I'm not too comfortable having TensorFlow installed onto my natural computing environment, just because of the fact that, say, I don't know, 10 months time they change the versions and I'm trying to run something else, it could interrupt and kind of cause some issues. So it's always best to use a virtual environment. Once you're done, you can deactivate it, you can throw it away. But the command to essentially create your virtual environment will be Python 3 -m, and then the command for the virtual environment, and then the name of the virtual environment, which in this case I'm going to call it env, and then that will create the file there. Now to activate your virtual environment, you want to source it, and then you want to go within this current directory, look for that env, look for the bin file, and then look for activate within that bin directory, and then that will create. And once you see that there, you know, brilliant, my file has been my virtual environment has been activated and is running accurately. Brilliant. So the first thing we want to do is we want to import TensorFlow. Now, of course, we want to import TensorFlow as TF. The reason why we import TensorFlow as TF is so that it's a shorthand, so that we don't have to keep writing TensorFlow every time we want to use TensorFlow. Now, we haven't actually installed TensorFlow within our virtual environment. And to do so, we want to do pip install TensorFlow. And then that will go ahead and it will install TensorFlow within that folder. Brilliant, that's all installed. And if you're following along, you will also see kind of a similar logs depending on the time and date that you're installing, you're watching it. Brilliant. So let's actually verify that TensorFlow has been installed. And what we can do is we can have it print out the version of TensorFlow that we're using. And that's the way that we would do so. And then if we go ahead and we run, we execute our script, which if you're using Visual Studio Code, the way you execute your script, one of the ways is actually use Python 3 and then call out the name of your file, which is TensorTest.py. Press enter. And then it takes a while to actually do that sometimes. But eventually it actually prints out the name, the version that we're using, which is 2.13.0, and that's the version that we're using here. So now that we've got that sorted and we verify that that works. I mean, same thing if you're using the Google Colab, feel free to verify that TensorFlow actually is. Feel free to verify the version being used. So if we run that here, we should get 2.12. Brilliant. So now that we've got that installed, let's go ahead and let's begin to train our model to be able to look at those coordinates and be able to extract details as to the relationship between the x coordinates and the y coordinates. Now, the first thing we should talk about, which for this model, we're going to use Keras, which comes as part of TensorFlow in this instance. Now, Keras has a number of models that you can use. The two main ones is functional API and sequential. Now, what we're going to be using for this particular tutorial is the sequential model, and the way we bring that in will be tf.keras .models, and then you call the sequential model, and then we serve it as an argument. Now, let me just dive a little bit deeper into sequential. The reason why we're using sequential is because for the most part, sequential is tailored for more linear tasks, essentially. Now, the graph that I showed you earlier is a linear graph, essentially. So using the functional API would have been an overkill. Now the functional API actually allows you to, if for example the model that you're training your TensorFlow on is basically, so the data you're using to train requires a lot of inputs. So here we only need one input, which is the x-axis. But say we were using something that required, I don't know, 10, 15 inputs to be able to give the outlines, to be able to give the output, then we'll be using something like a functional API, which allows you to build more complex types of models. So for this level, you just need to know that we're using the sequential as our model. And within that as an argument, we want to call in the layer that we want, which would be dense as the layer that we need. Now the reason why we're using dense, which is pretty standard, is essentially it allows us to access any neuron that's built from the previous layer. It allows us to gain access to that, and so within this one we're going to we only need kind of like one neuron in this, so we'll use the units equals 1, and then we'll use input shape to equals 1, and we pass that in as a list essentially. Now to help with the accuracy of the actual training of the model, so when I say accuracy, what I mean is to make sure that it's able to accurately determine that the next time you pass in an x variable, it can actually give you the correct value for that y. We need to compile the model, and we compile it with two arguments, essentially the optimizer and the loss functions. For now, that's what you need to know. I'll go into another video explaining in more details why we have those optimizer and those loss functions and the reason for these values. But for now, let's just go ahead and let's call in those arguments. So the optimizer, which will equate the value to be SGD, and then we'll take the loss also, and we'll equate that value to be mean squared error. Brilliant. And then now we can get to the main point, which is giving our model the coordinates. So giving them the coordinates in this case is the data. If we were actually working with the commercial example, so we would give it the raw data of the houses, so essentially the number of rooms, the garage, the location. But in this case, we're only going to give it the raw data of the coordinates that we want to predict for. So for this one, we're going to serve the information using Numpy. Now Numpy is a very important library as well as Pandas. So if you want to go into the AI engineering space, I think Numpy and Pandas is something you should probably spend time learning. It's really important, and I think even outside of the engineering space, it's actually quite fun to pretty much use, and kind of it's a computational library. It kind of allows you to access more I guess mathematical aspects of any kind of code that you're writing essentially. But for this purpose, we're going to serve it. We're going to serve our model in the data for our model. We're going to serve it in through the NumPy array. So we'll go ahead and so as you can see here, we've served it in, and in this instance, previously, I'm sure you noticed, we had it here as -1, -3, which we've got -1, -3. However, we're using decimals instead here. The reason why we're using decimals is because just in case, say we pass in a value of like, say an x value of like 100, for example, can we always guarantee that the value returned is going to be a decimal? It's going to be a non-decimal. Maybe we can. I mean, based on the formula itself, we probably could. However, we want to give it more freedom. So just in case the value of an x is going to not be a single digit, it's going to be a decimal digit, then our backs are essentially covered. So we use a float here. If it was an int, for example, then it would just give us single value. So we use the float there, and that's brilliant. Now we can actually go ahead and train our model. Now to train our TensorFlow model, we use what's known as we use the script fit. We use the function fit, and then we pass in 3 arguments. The first argument being our x variable, the second argument being our y variable. So we're passing in this, we're passing in that, and then the final one, we're passing in what's known as an epoch. Now the epochs is essentially how many times we feed in that data, so the array, how many times do we feed it into the model? So how many times do we feed it into our sequential model? And each time we feed it in is 1. So for this purpose, we're going to feed it in about 500 times. Now that means that it will pass it in every single time 500 times, and each time that it passes that model in, it passes that data in. Our model then learns that, okay, it learns something new, and then it can also look at the previous information that was passed and also learn from that. Now, the more you pass it in, the more accurate, essentially, in some cases, the more you pass, the higher the epoch, the more accurate your predictions can be in some cases. It's not always all the time. Now, to make sure that it actually works, what we want to do is we want to see it predict something. So we're going to print out a prediction, and we're going to say model.predict for us, and we're going to give it a value of 10. So we're going to say after you've learned these models and you've compiled, predict for us what happens when the x-axis equals 10. Now we know from just looking at the formula that when we pass in an x-axis of 10, our y should equals 19, right? Because 10, I mean, I hope my math is correct. 10 times 2 times 10 equals 20, minus 1 equals 19. So we should see 19, hopefully. Let's test that and see whether that's something that we'll see. So to run or to execute our TensorFlow, to execute a script, we'll do Python 3 tensor test, and hopefully there isn't any syntactical errors here. If there is, then we can fix that. But if there isn't, okay, then it doesn't look like it. So it runs that, and because we've used 500, which is a pretty high number anyway, it gives us a value of 18.985, which we can round up to 19. However, that's not too accurate. Let's say we use something lower. Let's say we use 100, for example, and just to cement in a point that the higher the value, the better sometimes it can be for the model. So if we use 100 and we run that test, we see that it goes 18.13. If we use, let's use a lower number, like let's say 10. Let's see how accurate that number becomes. Yeah, it becomes 8. So over here, we've used a pretty low epoch number, and as you can tell, the number is completely way off. The value of passing in 10 is not going to be 8. However, because we haven't fed in enough data and we haven't allowed the data to learn enough times, it doesn't actually give us a good prediction. So if we use something like 1,000, for example, and we feed that in, we should see that our number, the value that we get, should drastically increase. And in this instance, we get 18.999, which, you know, is quite close to that's quite close to 19 anyway. Now, if you were using and you were using the Google Colab version, I guess what you can literally do is just, for example, if we copied in what we just done here, if we essentially paste that in there and then run our predictions, and what I'll do is I'll change the epoch here to 500. I think 1,000 is a bit too high and it might take a while to run that. And then we run that that simulation. We should see it come close around 19, maybe not exactly 19, maybe like 18 point something. Yeah, so we get an 18.98, which is pretty close to what we got when we run it here. Now, I hope you actually enjoyed. Let me bring back the PowerPoint. I hope you actually enjoyed this particular tutorial. I certainly enjoyed learning about TensorFlow, and especially those models. So the difference between the sequential and the functional API. For the next couple of videos, what we're going to do is we're going to go more complex. So this was essentially a very small high-level example of how you can basically get your feet into machine learning, into deep learning, into artificial intelligence. This is where it all sits on. I hope you really enjoyed it, and if you sat through the whole of this video, I hope you learned something, but if not, that's okay. Thank you very much for your time. I hope you enjoyed this tutorial, and see you next time.